Hi, today we're going to look at the law of cosines, and we have been able to solve triangles at this point. Any right triangle we can do by using our SOHCAHTOA. And then we learned that, well, if you don't have a right triangle, you could use the law of sines. But the thing is that sometimes they just don't give you exactly what you need for the law of sines. So we have another method, it's the law of cosines. We won't look at where it comes from, but it is derived from using the law of sines. Let's look at an example. This is our law of cosines, and if they don't, and again, it is used on non-right triangles, typically. We'll stick with SOHCAHTOA on the right triangles. If it's not a right triangle, we're going to do law of sines. If they don't give us what we need for law of sines, then we're going to go to law of cosines. Okay, so this is the formula. It looks kind of big and scary, but it's really a very straightforward formula that you'll learn pretty quick. Now, the way it's set up, and there's nothing magic about the A, B, and C. I could rearrange the A, B, and C, but what you have is you've got one side squared is going to equal the sum of the other two sides squared minus twice those same two sides. Those will always match. Times the cosine of the angle that is across from the side you're looking for. All right, again, don't get caught up on the A, B's, and C's there. I could just as easily have written this formula like this. It could be B squared equals, and then it's the other two sides squared, minus 2 times those same two sides, times the cosine of the angle across from what I'm looking for, so it'd be the cosine of B. So don't get caught up on your A, B's, and C's. Okay, now before we jump in, there's a couple things we need to acknowledge about the law of cosines. Okay, so we're going to generally use the law of cosines just one time. And then that'll give us one more piece of information that we can then go back and use our law of sines, because the law of sines is probably going to be quicker in the long run. So we'll do the law of sines once, or I'm sorry, the law of cosines once, and then revert back to what we learned yesterday. Now, what missing piece of information should we get? Well, sometimes it doesn't matter, but the one thing that you need to acknowledge is that if you ever do the law of sines, your calculator will not give you an obtuse angle back. And that's something you'll have to learn more about in a full trig class, but keep that in mind that we're going to want to use the law of cosines to find obtuse angles, not the law of sines. Another option would be just to wait till the end and find that obtuse angle by subtracting from 180. We'll look at some examples and I'll tell you what we're looking for here. All right, so here's an example. They've given me 3 sides here. I've got side A, side B, side C. I could not set up law of sines on this because remember you have to have a matching letter and angle, or a matching side and angle so that you can set up your law of sines. So I don't have that here. So that's going to be my clue that I'm going to be using law of cosines. Now, remember, the one thing you have to watch out for is being careful with that obtuse angle. Now, not every triangle is obtuse, but you got to kind of approach it like it might be. So when I look at this, since side C is the longest side, if there were going to be an obtuse angle, it would be angle C. So since it doesn't really matter which angle I'm looking for here, because, I mean, when I say it doesn't matter, I've got 3 sides. I could go any way I want with this. I'm going to purposely go for finding angle C, which means out at the end, I'm going to want it to say cosine C, which means, remember, that you start with that same side. So here we go. We're going to have C squared, and maybe I'll write it here this first time. We won't always do this, but C squared equals A squared plus B squared minus 2 times those same two sides times the cosine of the angle across from that, so cosine of C. Okay, so we know everything except this angle C. So we'll fill it all in and we'll go solve. So c squared, that's going to be 18 squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of angle C. All right, so I'm just going to start doing some algebra, isolate that angle C. So I'm going to subtract the 10 squared, I'm going to subtract the 12 squared over to this side. So minus a 100, minus a 144. And let's see what that gets us. I've got 18 squared minus 100 minus 144 ends up equaling 80. And that's going to equal, now be careful how you do your algebra on this. This is all one term. It's all being multiplied together. So I'm going to go ahead and take the negative 2 times the 10 times the 12. So negative 20 times 12 ends up being a negative 240 cosine C. And so I'm going to divide by negative 240, which actually would reduce nicely, but I'm going to go ahead and go decimal on it because we're just going to be typing it in our calculator anyway. So I'm going to end up with a negative 1/3 or a negative 0.3 repeating equals cosine C. And now we're at that stage where we're looking for the angle, so we'll have to do inverse cosine. So I'll do second cosine. I like to do second answer if you had put the 80 divided by 240 in there so that you get all the decimal places. But in the end, angle C is 109.47 degrees. That is an obtuse angle, so it's a good thing we went this route to find it because the law of sines would not have given us that number. Okay, so we have angle C found. I'm going to write that up here. Angle C is 109.47. Okay, now we have to find the other angles, and like I said, you're typically going to do law of cosines once, and then you're going to shift over and do law of sines. Since I already have the obtuse angle, it doesn't really matter which one I find. I just know that I'm going to have to do side C, 18, over the sine of angle C, so sine of 109.47. Got to use that information. Those are my matching letters. Equals, and then let's say we're going to look for little a, or I'm sorry, angle A. So I'll put little a, let's just put the number there. So we'll put little a, which is 10, over the sine of angle A. Notice we're looking for the angle here, so we'll have to end up doing our inverse, but we're going to cross multiply, and we're going to divide by 18. So that means I got 10 times the sine of 109.47, and then I'm going to close that parenthesis, and I'm going to divide it by 18. And I end up with a 0.523 or 524, something like that, equals the sine of A. And so since I'm looking for the angle, I'm going to do second sine, second answer, and I get angle A to equal 31.59. Okay, so that's my next angle that I was looking for, 31.59. And then I could do law of sines again to go find B, but you know, it's pretty easy just to subtract from 180. As soon as you know two angles, then you can just subtract those both from 180 and you'll have your last angle. So angle B looks like it's going to be a 38.94. All right, so those are our three angle measures that we were looking for. Okay, let's try one where they're not giving me the three sides. This time, they did give me an angle measurement. I have angle C is 75. But notice that I don't have side C. So I couldn't do law of sines here because I don't have matching letters. Now, remember that thing in the back of your mind. You're always supposed to be aware of the obtuse angle, any potential obtuse angle. Well, I'm kind of stuck here because they gave me the angle C. I have to use what they give me. So I'm just going to keep it in the back of my mind. There might be an obtuse angle, but I'm going to use the angle C that they gave me, which means that I'm going to have to start off and I'm going to have to do C squared. Since they gave me angle C, it'll be C squared equals A squared plus B squared minus 2AB cosine of angle C. Okay, so let's plug in what we know. This is actually a quicker way because what we're looking for here, we know all of this stuff. So basically we're just going to enter this all in left to right in our calculator and find our little C. So it's going to be C squared equals 6 squared plus 10 squared. You could just write that 36 and 100 if you wanted. Minus 2 times 6 times 10 times the cosine of 75. We know everything right here. Be careful. A lot of times we get tempted to take the 36 plus 100 and then subtract. This looks like 120. And then we press enter and then we come back and do this. This is all being multiplied. This is all one thing together. Order of operations says I have to do all that multiplication in there before I would do that subtraction. It is in your best interest to just enter that left to right in your calculator. So here's what I'm going to enter. I'm going to do the 36 squared in my head. So 36 plus 100 minus, and I could do this in my head, and that would be great. I'm just going to go ahead and do minus 2 times 6 times 10, because those aren't always going to be nice, easy numbers like that. And then I just hit times cosine 75, and I've never hit enter yet. I just did that left to right in my calculator, press enter, and I've got it. C squared is equal to 104.94. Last step, square root both sides. So I end up with little c equaling 10.24. Okay, so that was one of the missing parts, little c. So I now have all three sides. What I'm looking for still, I guess, is angle A and angle B. Now, if I look at my angles, well, really what I'm looking at is I'm looking at my three sides. Now that I have three sides, remember that the largest angle is across from the longest side. So when I look at my three sides, I got a 6, I've got a 10, and I've got a 10.24. So the longest side is this little c right here. So since that's the longest side, if this triangle was obtuse, angle C would have to be the obtuse angle. Now the thing is they gave me angle C. It's 75. It's not obtuse. And so basically 75 has to be the biggest angle. So it doesn't look like I've got an obtuse triangle on this one because 75 is the biggest angle. I'm good to go. I can just run it through law of sines. If by chance this little c was smaller, let's say that that was only 9.24, then I would look at B and say, oh, B is the longest side, so if there was going to be an obtuse angle, it'd have to be angle B. Now, what that means is that, oh, okay, well, be sure to not use the law of sines to find angle B, if that were the case. I would have to do law of sines to find angle A, and then just subtract from 180 and get your other angle that way. So, again, just always have to be aware of what that obtuse angle would be and make sure you're not using the law of sines to find it. Okay, as I mentioned, we're not worried about it on this one. So let's just set up a law of sines. I've got my matching letters. Now I have the c's, so it's 10.24 over the sine of 75 equals, let's look for A, so it's 6 over the sine of angle A. All right, so then I'm going to cross multiply and then divide. So 6 times the sine of 75, divide that by 10.24. Remember that you're always closing that parenthesis. I end up with a 0.57. But since I'm looking for an angle, I know I'm going to do second sign, second answer. And so I get angle A to actually equal 34.47. Okay, so now that I know angle A, I could set up law of sines again to go find angle B, but remember it's your third angle, so really you could just subtract that and the 75 from angle C from 180, and so I get angle B to be 70.53. All right, law of cosines, it's a pretty quick little thing to use. Okay, last thing is a formula to find the area of a triangle. And it's, you learned how to find the area of a triangle probably back in the 4th grade or something, where you just do the area is equal to 1/2 the base times the height. Okay, well, the problem with that formula, not that it's bad, but a lot of times when you're working with a triangle, you don't necessarily know the height of the triangle in there, which you would have to have for this formula, because it's not really a part of the triangle, it's on the interior of that triangle. So we have a formula, Heron's formula, that is also used to find the area of a triangle, but it is used not by knowing the base and the height, but by knowing the 3 side lengths of your triangle. If you know the 3 legs, this is our area formula. All right, so a couple things. So you want to jot it down. That's your area formula. The A and the B and the C are just the 3 sides of your triangle. And the S is equal to 1/2 the perimeter. So if you know all 3 sides, you can find what your perimeter is. So once you know that information, so you're going to use this every time you know all 3 sides. If you don't know all 3 sides, you go back and do law of sines or law of cosines to find the missing part. Then once you know the 3 sides, you can use your Heron's formula. So for this particular example, I'm going to go ahead and just give you the 3 sides. So we don't have to do law of sines or cosines to find anything missing. I've given you what you need. So I've got 3 sides. That's 11 plus 10. Okay, so my perimeter is 21. So if the perimeter is 21, then little s is going to be 10.5. Okay, so that's the half perimeter. So if I'm going to put in 10.5 for s, I just plug it in. Area equals big square root. I'm going to put in the s value, 10.5, and then I'm going to have 10.5 minus a. So I kind of like you to do some mental math, but since it's notes, I'll write it out. 10.5 minus 7, we should know, is 3.5. All right, and then you've got 10.5 minus your b value, so that's going to end up being a 6.5. And then the last one, I've got 10.5 minus c. Okay, well that's just going to be 0.5. So then you just go to your calculator and you type that in. And sometimes it'll be easy to do the mental math on it, sometimes not so much. On this one, I can do some mental math. So I'm going to do a big square root, and then I'm going to type in 10.5 times 3.5 times 6.5 times 0.5. Close that parenthesis, take the square root of all that, and we should end up with the area equal to 10.93. And if they give you units of some sort, then you can write that. I would just write units squared, because remember it's area, so that would be the area of it. Quick, easy formula to find area. Nice one. Just have to know the 3 sides to be able to use it. All right, good luck.